right, now let's begin. I will also, in the first chapter, I will jump around the way the textbook and the way they have it set up. I don't really like it that much. So I will try to follow along their outline, but it's not, to me, it's not fluid. It's not logical. Because, well, first off, when we say algebra, what do we mean? What is algebra?
Numerals and numbers.
Is that it? So if that's the case, all we have to do is learn how to count.
And letters.
Graphing, letters, letters called variables, yeah.
Equations.
Equations, yeah, that's a big part of it. What else?
I would say fractions. Fractions.
What is it used for? What is algebra used for? Everything. Your cell phone, your car, your computer, your glasses, your shirts, your shoes. Everything had to be verified numerically by mathematics before any company would waste money and time building it. Mathematics pretty much is the language used to define our universe. Everything we do is mathematics. The weather forecasts, that's all mathematical. So what we have to do now is we have to start with the basic rules and discussions to move up from there. So even before what the textbook talks about, we have to talk about the properties of math. The properties of math tell us what we can do. The order of operation tells us when we should do it. This tells us what we can do. The first property is the commutative property of colon. What does to commute mean? Commutative. You ever heard that word before?
I've heard more.
Commute, yeah. Commutative means something that can commute. When you drove from your house to here, you commuted by car, by bus, by boat, by bicycle. Basically, to commute means to move. Now, because there's a colon at the end of it, that means we have a list. In our list, we'll only have two possibilities. We'll either have addition or multiplication. Now, I'll spell out the first one. Addition, multiplication. So what I'm going to have here, I'm going to have the general rule here. I'm going to have an example here. So the commutative property of addition says this. X plus Y is the same thing as Y plus X. 3 plus 4 is equal to 4 plus 3. They both equal 7. So it doesn't matter how we arrange them. Same thing with the multiplication. X times Y is the same thing as Y times X. 3 times 4 is the same thing as 4 times 3. They both equal 12. So that's the commutative property. We can move around numbers if we need to. The second property is the associative property of. What does it mean to associate? when you associate with your friends, what you have just done is you just formed a group. An association is a group of people or a group of companies or a group of an entity of some sort, group of entities. Again, we have multiple of them. For addition. Now, here's another property. Here's another rule of everything in general. X plus Y plus Z equals X plus Y plus Z. True? X plus Y plus Z. That is true. It's the same thing on both sides. But nothing in our known universe, if we have 3 plus 4 plus 5, so whenever you have letters, all they mean is that just takes place of I can put any number I want to in there. I can put any number I want to in there. But if I give you these numbers, how would you solve it? Yeah, that's the most logical thing. 3 plus 4, and then whatever that is plus 5 to both sides. But that doesn't do us any good here. So nothing in our universe can process more than 2 numbers at any one time. Even the fastest computer has to break it down to 2 pieces to do any operation. So what we have to do here is we have to tell the computer or tell our brains which 2 do we put together first. That's what in order of operations you have the special operations. Parentheses, do everything, or I could put brackets in there from a 2, or I could put anything to combine them. But this thing tells me I have to do inside the parentheses first. 3 plus 4 is 7. 7 plus 5 is 12. 4 plus 5 is 9. 3 plus 9 is 12. For the multiplication part, X times Y times Z is equal to X times Y times Z. This rule, this property, the importance of it is better exemplified here in this example. Work those out. Which side is easier to do? By far, yeah. Because in this one, 3 times 4 is 12. 12 times 5. Well, 5 times 2 is 0. Carry the 1. This side says 3. 5 times 4 is 20. 3 times 2 is 6. Put a 0 behind it. So if you have a series of numbers, you can pick which ones to do first if they're the same operation.
Doesn't matter which side you choose.
Nope. If as long as the operations are the same. In other words, if I had addition and multiplication together, then I'm limited in what I can do. So these apply, since all of these are multiplication, I could pick whatever 2 I could put together first. Also, because I could use the commutative property, I could do that. The commutative property says I can move the 5 over. Commutative property says I can move the numbers around. 3 times 5 is 15. 15 times 4 is 60. So anyhow you need to, you can move them around. So for the first two properties, we had to separate the multiplication and addition. The third property is probably the most important one that we deal with. You notice it doesn't have the word of at the end of it. The distributive property is one property by itself. It combines both the addition and multiplication. How would you read that? How would you read that? Now, how would you read it? Not what, how would you do it? How would you read that? Very good. That's exactly how you'd read it. That's exactly what it's telling us. Because remember, mathematics is a language, it's communication. What if you're talking to a friend over the phone? How would you define this to him? A times x plus y. This number in front has a name. What is it called? The number in front of anything is called a what? I'll give you a clue. Starts with a C. Coefficient. Very good. Very good. Whenever you hear the word coefficient, that means the number in front. What this property tells us, and I'll tell you why this rule is important. What this one tells us is A times whatever this is. So what this tells us is if we can't combine x and y, we have to get rid of the parentheses. We use distributive property to do that. So what it says is A times x is ax. A times x. This is positive, that's positive. So A times y. So the distributive property allows us to get rid of parentheses. Gets rid of parentheses. We used to have parentheses, but here's the beauty of the distributive property. It has two purposes. If you go this way, that means you take this number and you expand it. We can also go this way. I can give you this, you can give me that. This direction is called distributivity. This direction is called factoring. We're going to use that a lot in this course as well. How does factoring work? What do they both have in common? What do these two terms have in common? AX, AY. What do they have in common? They both have the A in common, right? So since they both have an A in common, we take it out. And whatever is left, we put inside the parenthesis. So if they both took out the A's, we have X plus Y. That's how factoring works. But that all puts in the guise of distributivity rule. So how about this one? What do they both have in common? Right. Because over here we have 3x. What is 9 made up of? 3 times 3. They both have what in common? They both have 1, 3. So if I take out that 1, 3 they both have in common, whatever's left goes inside the parentheses. X plus 3y. That's how factoring works. How do we know that's right? Well, multiply it. 3 times x is what? 3x. 3 times 3 is 9y. Always check your work. Make sure what you've done is correct. So far, so good? Because how many have ever seen these rules before? This is how math should start. When you first learn math, this is how you should have started. You have to know the rules, what you can and what you can't do in math. Because if you do something you can't do, your answer is going to be wrong. Then we have another property. The inverse property of. What does the inverse mean? In one word. Opposite. Very good. It was on the tip of your tongue. I knew it. The inverse property of addition. So, what can I add to x to make it 0? Because if you add opposite numbers, what happens to it? They disappear. What's the opposite of x? Negative x. Very good. If we look at a number, if opposite of 3 is negative 3, why is that the opposite? Let's look at a number line. When we say opposite, we mean the opposite side of the 0 line. If this is 3 here, what's the opposite of it? Negative 3. And multiplication. How do we get rid of x? What do we multiply to x to get rid of it? No, then it'd be, if it was negative x, it'd be x times negative x, wouldn't be positive times negative is negative. X times x is x squared. So it's not the same as the addition property. Very good. It's 1 over x. No, don't close it. No, that's why I put the trash can there. Because remember, we wanted to get rid of this x, so we added by negative x. We want to get rid of this x here. What is this? What does this number really look like? In other words, if I had 3, what do I multiply to 3 to make it equal to 1? 1 over 3. Why is it 1 over 3? Exactly. Every number is a fraction. every number is what a fraction. Those are called rational numbers. Every number can be written like that. 3 can be written as 3/1. 2/3. That's already a fraction. So the inverse of a multiplication is simply the flip of it. What would the inverse of 2/3 be? 3/2, right? It's the flip of it. The nullity property. X plus 0 equals what? Three plus 0 is what? So x plus 0 is x. Anything plus 0 is itself because it doesn't go anywhere. X times 0 is what? Very good. 0. So 3 times 0 is 0. What ruined many students' brains in junior high and high school was when they started to use calculators to do your thinking for you. Your brains became mush. Don't use calculators. Use a pencil and paper. Do the math in your head. Do the math on pencil and paper. Use a calculator to check your answers, not to do the work for you. Now we'll leave it there. All right, so that's the first part. So section 1. Intro to graphing. When we first learned numbers, we learned what are called natural numbers. What are natural numbers? 1, 2, 3, all the way up to infinity. Another name for them are called the counting numbers. When you're asked to count, you always start at 1 and go on for always that way. Okay, so in elementary school, you first were taught those numbers. How were they represented to you? How do you display those numbers? Very good. And so on and so forth. The number line. If you go to a lot of schools, elementary schools, pre-K classes, you'll see always starts at 1 and goes on from there. Well, do we have any other numbers in that? Yeah. What's to the left of 1? Well, we call those whole numbers. Easiest way to remember that is it begins with a whole. So now we have a beginning point. We had to discuss 0. Why? Because what does 1 mean? We know we use these numbers all the time, but what do they mean? How did you learn numbers? What does 5 mean? Of a quantity of items, right? When you first learned, you had a picture of one item. The teacher showed you one ruler or one pencil. Then they showed you 2 pencils. So the numbers are associated to some sort of symbol. Well, in the number line, 0 is nothing. You have nothing. If you have 1, you take 1 step forward. If you have 3, you take 1, 2, 3 steps forward. So these numbers are distances from 0. How far? The number 3 is 3 units away from wherever there's a 0. Why is that important? Because now we move on to the next type, integers. Do we always have to go to the right? No. Integers allow us to go both directions. If you go to the right, we have to call that positive. If we go to the left, we call that negative. The distances are still the same. -3 is still 3 units or 3 steps away from 0. +3 is 3 steps to the right. So positive and negative are simply directions. What's the next thing you learn? Fractions. Rational numbers are fractions, where A is less than B and B does not equal to 0. A is less than B and B is not equal to 0. -1/3, -5/7. Why does the top have to be smaller than the bottom? These are called proper fractions. Because a fraction, now let's just look at these are all 1/5. 1/5, 2/5, 3/5, 4/5, 5/5. Because they have to be smaller than the entire picture. If the top is bigger than the bottom, then we have what are called improper fractions. Because rational numbers, proper fractions, the answers have to be less than 1. Less than or equal to 1. 1/3, is that less than 1? 5/7, is that less than 1? Yeah. But how many times does 3 go into 5? With how many left over? So an improper fraction says, okay, I'm dividing it into 3 parts. I have to go 5 of them. 1, 2, 3, 4, 5. That's what 5/3 means. It's bigger than 1 now. So what do we call these numbers? Improper fractions, the top number is bigger than the bottom. We convert them to these type of numbers, which are called mixed numbers. Why are they called mixed numbers? Because you'll have an integer and a proper fraction. You'll have an integer and a proper fraction. This is nothing new. You've seen this all before in 5th, 6th, 7th grade. So whenever you have an improper fraction, three goes into 5 once. 1 times 3. 5 minus 3 is 2. This number is your integer. Your remainder and whatever's on the bottom always goes on the bottom. So what would this number be? Convert this one. Quietly. So much for quietly. But you're right. 9 goes into 14 one time. 1 times 9 is 9. Subtract those, I got 5. I can't go any further, so it's 1, 5 over 9. This will always be the denominator. What if I gave you a mixed number and I asked you to convert it to an improper fraction? How would you do that? Yeah. Let's see. Anybody else know? The formula is this. The bottom number stays the bottom number. Take the whole number, multiply it to the bottom, and then add the top number. That's the formula. So the bottom number stays the bottom number. 2 times 5 plus 3. 10 plus 3 over 5, which makes it 13 over 5. the my lab math will ask for a lot of fractions as answers, which is where calculators are useless. Calculators will always give you an answer in what form? Decimals. That's not what we want. The rule of mathematics is if you start off a question with fractions, you have to end with fractions. If you start with decimals, you end with decimals. So again, do not get trapped by using calculators. So again, we're building our number line. To the right is positive, wherever zero is, to the right is positive, to the left is negative. To negative infinity, to positive infinity. The horizontal line we call the domain. The domain are all of the numbers we can use horizontally. We're going from negative infinity to positive infinity. We call those all real numbers. The symbol we use for that is that R symbol. So if instead of writing this, you can just put that symbol and it's the same thing. At the end of chapter 1, we're going to deal with inequalities, in which we're going to, if I give you a number line, we're going to discuss how we get different formats and different answers. But that's at the end of chapter 1. Don't worry about that right now. Again, this is our domain. These are the horizontal axis. That's what they used to use for a long time. And then it was a guy in France named Rene Descartes who was sick one day and lying down in bed. It was like the ceiling we have here. He noticed a spider moving on the ceiling. He realized, hey, I can tell you exactly where that spider is. Because if that is the beginning I'm looking at, I can count how many spaces this way and how many spaces that way. So what Rene Descartes determined was a grid. We have a beginning. To the right, we call those positive. To the left is negative. Up, we'll call those positive. And down, we'll call those negative. Because they're directional. He defined this as the x-axis and this one as the y-axis. They have names. Anybody know their names? That's these parts, right? but X and Y axis, they have names. D. Call the X-axis the ordinate. And the Y-axis, he called the abscissa. No, hold it backwards. Because this one came first. So that's the abscissa. This is the ordinate. What is the word? Well, what do we call this chart? The y-axis is the ordinate. The x-axis is the abscissa. What do we call this chart? It is a grid, but it's got a name. Yeah, you call it the grid or the XY chart, but it has a name before that. It's called the Cartesian coordinate system. Cartesian, because that's the name of the person who found it, Rene Descartes. Coordinate. There's it. So we have an x-axis and we have a y-axis that goes along with it. So it's a coordinate system. So he was lying down in his bed and his spider was over here. It's a language. How would he describe the location of that spider? The spider is at a point on this grid. Its location is always the x-axis first and then the y-axis, horizontal then vertical movement. So where is that spider? It's at 2, 3. So he would say that the spider is in coordinate 2, 3. Well, how come it's 2, 3? Because you start off here at the beginning, you go 2, it's positive, you go to the right, and then you go up 3. Because it's positive. If the spider was over here, what would be its coordinate? Right. -3, +1. So you start from the beginning, go -3, left 3, and up 1. What's that location? Right. Go to the left 2, and then down 4. And that one, 2, -3. So we go 2 to the right and or 1, sorry. Go over 1 and down 3. So that's how Rene Descartes figured out this coordinate system works. And yes, we do have 4 of these. They're called quadrants. Why are they called quadrants? Yeah, because quad means what? 4. There's 4 of them. Why is it situated this way? would we label it this way? Today? That's right. No. The reason this was because they didn't have clocks back then. They had sundials. The sun rose where? In the east and set in the west. So the sun would go like this. And then it continue. So that's the reason it's backwards to what we would do nowadays. And each of these quadrants, we notice that the points have unique sign coordinates. In the first quadrant, both numbers are positive. In the second quadrant, the first number is negative, the second one's positive. In the third, they're both negative. In the fourth, it's positive and negative. Because remember, each point is made up of an X and Y. X goes left and right, Y goes up and down. What do we call the middle point here, where everything begins? The origin is where it all begins. It has a coordinate of 0, 0. From 0, 0, we go positive to the right, negative to the left. And then from that point, we go up or down, positive or negative. So that's where we find our points. So I'm going to give you some points here. Plot those on a grid, but before we do that, tell me which quadrant they're in. On your own paper first. I'll give you 2, 4, 6, 8 seconds. By looking at these points, you can tell me what quadrant they're in. So which quadrant is the first one in? Next one. Next. Next. Nope. Because if we were to graph these, that was a trick question. It's on an axis, exactly. So the first one, we go -3 and up 5. Next one, we go to the positive right 4 and up 3. 3, up 4. Back to the left, -4, down -2. 3, down 4. But this one says, how would it go? Do we go anywhere left and right? Nope, we just go up 4. 1, 2. Those are called interquartile. Those are on the axis themselves. And this one is -3, doesn't go up and down. And this was at the origin. So far, so good. These, if they land on the axis, they have another name. If it lands on the y-axis, it's called a y-intercept. You notice the y-intercept, the value of x is 0. And if it lands on the x-axis, it's called the x-intercept. And if you notice about the x-intercept, the y value is 0. So for the x-intercept, the y equals 0. For the y-intercept, the x equals 0. So far, so good. Because now we're going to look at describing how graphs of lines and curves and stuff like that, how they relate to all this stuff. This is solutions to equations. What defines an equation? If it has an equal sign, right? Is that an equation? Nope. What is that called? It's called a statement. All you do with statements are you simplify them. If it has an equal sign, those are equations because it has an equal sign. And with equations, you solve them. When you solve them, you're not done until the letter, the variable, equals a number. That's what we mean when we say solve. So for the example, we had 2x plus 3y equals 18. Which one, or if any of them, are solutions to that equation? In other words, are either of these points on this graph? How do we do that? This is a point. How do we know it's a point? Yeah, as a parenthesis, every point has an x and a y. So my x is equal to -5, and my y is equal to 7. Plug those in there. 2 times -5, 3 times 7. Work it out. Do these operations sequentially. Do the signs first. Positive times negative is negative. 2 times 5 is 10. Positive times positive is positive. 3 times 7 is 21. This is where more troubles occur. Okay, normally the first thing you do, pop out your calculator and start typing the stuff in there, but you don't have to. Elementary school kids do this. Is the answer going to be positive or negative? Why? Because 21 is bigger than 10. 21 is positive, so the answer is going to be positive. What is 21 minus 10? Does 11 equal 18? So that's not a solution. It's not a solution, which means that point is not on the graph. How about 3, 4? Is that point on the graph? In other words, is this a solution to this equation? Well, let's work it out first. X equals 3, y equals 4. 2 times 3, 3 times 4 equals 18. 2 times 3 is 6, plus 3 times 4 is 12. 12 plus 6 is 18. So the 0.34 is a point on the graph of 2x plus 3y equal 18. Hence, it is a solution. How would you graph this equation? Yes, but there's more than one way to skin a cat. But that's one of the ways, yes. What you're saying is solving for y first and then go from there. But looking at this equation, what can you tell me about it? What kind of graph is it going to be? What kind of equation is it? First question. In other words, is it linear? Is it quadratic? Is it cubic? Is it rational? And so on and so forth. You can tell a lot about an equation just by looking at it. First off, you ask yourself, are there any special operations on the variables? What is a variable? What's a variable? The letter, yeah. X and Y are the variables. Because I could, as we just saw, I can plug in any numbers I want to in there. Only some of them will work. So do they have any special operations? Are there any squares? So do they have any exponents? Do they have any square roots? No. Because they don't have anything like that around them, this equation is a linear equation. What does linear mean? Right. It means it defines the first four letters, a line. What do we know about lines? They're straight. Yes. They continue infinitely both ways. And each point has to follow a special format to the next point. So what we would do first to graph this solve for y. So we have 2x plus 3y equals 8. We're solving for y. What do you have to get rid of first? Let's get rid of the 2x. How do you get rid of the 2x? Subtract it. Because remember, since we're solving for y, how is 2x connected to y? It's added. So we just do the opposite of this number. Since it's positive 2x, we subtract 2x from both sides. 2x minus 2x cancels. So it's minus 2x plus 8. Remember, we're solving for y. How do you get rid of the 3? How is 3 connected to y? It's multiplied. What's the opposite of multiplication? Now you divide. Divide each term separately. Oops, I'm sorry. So it's 18. It's 18. I'm sorry. It's 18. So the 3's cancel. So we have y is equal to negative 2/3 x. What's 18 divided by 3? 6. So now we have a formula. Yeah. Since we have a formula, we can plot some points. We know it's linear. To draw a graph of a line, what do you need? 2 points. Why do you need 2 points? If I give you 1 point and I ask you to draw the line that goes through that point, how would you draw it? Like this, like this, like this, like this, like this. There are infinite number of lines through that 1 point. So to define a specific line, I need 2 points. Once I have 2 points, then there's only one line that can go through both of those. So to find 2 points, pick any value of x. You can pick 1. What would be the easiest number to pick? Yeah. Why is 0 easy to pick? Yeah, Because if we had negative 2/3 times 0, what's anything times 0? 0, so it's gone. So it's always going to be the constant. One's not a bad number to pick, but look what's going to happen. If we put in 1 inside here, then we have a fraction and a integer. Yeah. Is there a better number we can pick other than 1? Because whatever we pick, we have to multiply by negative 2/3. Pick a number that can be divided by 3. Yeah. For example, if I had 3, I have negative 2/3 times 3 plus 6. The 3's cancel. Negative 2 plus 6 is positive 4. Whenever you have fractions, always look for the numbers that you put in there. Look for numbers that'll cancel with that bottom one. It's just going to save you time. It's going to be the same graph. It's just going to save you time doing the calculations. So do we have our 2 points? Our 2 points are 3, 4 and 0, 6. Remember, a point is the x and y component. So we have a point at 0, 6. And we have a point at 3, 4. Now we could just connect those 2 dots, and we have our line. So far, so good. There are a couple of ways we can solve these things. Another method you could use to try to solve it, besides plotting points, is the intercept method. Intercept method. The intercept method says try finding the x-intercept and y-intercept first. This method doesn't always work, but it's an easy way to start. To find the x-intercept, 2 steps. Set y equal to 0. And solve for x. And that's going to be your point. That's going to be your x-intercept. To find the y-intercept, set x equal to 0 and solve for y. And that's going to be your y-intercept. This method only really works if you can find these things. So sometimes you may find the x-intercept but not the y-intercept, or vice versa. So first off, x-intercept. What do we do first? Set y equal to 0. Anything times 0 is, so pretty much what we're doing there is just erase that y variable, that part. So what we have now is 2x equals 18. How do we solve for x? Divide both sides by 2. X equals 9. So we have 9, 0 is our x-intercept. And the y-intercept set x equal to 0. So we have 3y equals 18. Y equals 6. So the y-intercept is at 0, 6. All we do now is plot these 2 points, connect the dots, and you're done. We have the first one, 0, 6. So we do the other one. So that's one way of graphing equations. Let's practice those. Example 3. Graph this equation. Will the intercept method work here? No, why? Right. So we won't be able to find the x-intercept. So what's another way of doing it? Yeah, so we solve for y. First step, get rid of the x. How do we get rid of the x? The x value? Subtract 3x from both sides. So those cancel. So we have negative 5y equals negative 3x minus 10. Since there's a negative in front of the 5, our next step is to, across the board, change all the signs. Now divide by 5. 5's cancel. 10 divided by 5 is 2. Now we plot some points. What value do you have to pick first? Oh, yeah. Well, yeah, but we have x and y. Can we pick a value for y and solve for x? You can, but that's gonna be extra work. We're gonna pick a value for X. That's why X is called an independent variable. X is independent. Once we get it in this form, we can pick any value we want to and plug it in for X. Y is what's called the dependent variable. Because the value of Y depends on whatever X you pick. So in this equation, what's the first X we're going to pick? 0. Actually, I should ask you, what kind of equation is this? What's the graph going to look like? It's linear, so it's going to be a line. So if we pick 0, 3/5 times 0 plus 2, that disappears. So Y is equal to 2. What's another value of X we can pick? 5. Yeah, because the denominator is 5, so we pick 5. 3/5 times 5. The 5's cancel. 3 plus 2 equals 5. So those are our points. Zero, 2, that's our first point. Then 1, 2, 3, 4, 5. Go up 5, 1, 2, 3, 4, 5. And connect the dots. And there's my graph. Pretty easy. There's a shorter way of doing that, which we'll get to in a second. Well, I'll show you now. When we solve for Y, we get this equation. Only works for linears. You notice that this number here, whenever we put X being 0, it gives us the Y-intercept. So the constant number, when you solve for Y, the number that's a constant, that doesn't have any X around it, is always your Y-intercept. The constant of an equation will always be the Y-intercept. Why is this called a constant? Because can 2 ever change? It's always going to be 2. It's constant. It's always going to be 2. So the constant in an equation is always your Y-intercept. So we know it's going to cross at 2, at positive 2. This number in front of the X is called the slope. Every pair of points has to have a relationship between them. Since the top number is positive, from this point, we go up 3. 1, 2, 3. And then we go, since 5 is positive, we go to the right. 5 spaces. So the slope is either going to be up or down. Up if it's positive, down if it's negative. And the bottom number is always going to be positive. It always goes to the right. In fractions, if you have a sign on it, that negative always goes to the top number. If you have an equation that looks like either one of these guys, that whatever is a negative always goes to the top number. The bottom number is always going to be positive. It always goes to the right. All right, so that's another important factor. Why is that? Well, if we had if we're adding and subtracting fractions, you have to have a common denominator. Then whatever else stays on top. So the bottom number is always going to be positive. 3 minus 4 is bigger than 3, so it's negative. 4 minus 3 is 1. So whenever you have fractions, negative signs, if there's in front of it, goes to the top number. Why is that important? Because what if we had this equation? All right. What if we had that equation? How would you graph that? Start with, always graph the y-intercept first. And then follow the slope. So for this example, we'd start off at positive 2. So then from the y-intercept, follow the slope. The slope is whatever's in front of the x. So the slope of this equation is negative 2 over 3. The top number, remember, it goes up or down. It goes up if it's positive, down if it's negative, and always to the right. So this one says we go down 2 and then over 3. And there's our graph. Yes.
Now, would it be that simple, is there ever a time where you want to be that simple, you choose that method to?
If it's a linear equation and we get this point, it's always gonna be that simple. Yeah, that's the beautiful part about it, once you get that. But will they always be? Will they always be that simple? Well, no. Is this linear? No, because it's got a square. Because it has an exponent. The biggest exponent is called the degree of an equation. So the degree, if it's a 1, if there's nothing up there, it's linear. If it's a 2, then it's quadratic. If the degree is 3, it's cubic. If it's 4, 5, and 6, it has other names, quartic, quintic. And remember, the degree also tells us the maximum number of solutions possible. When we say solutions, we're talking about x-intercepts. So a linear equation has how many solutions? One. This equation is a quadratic. How many solutions is it going to have? Two, at most two. Because if it's quadratic, it can look like this, it can look like this, or it can look like this. You can have two solutions, one solution, or no solutions. So can we just pick 2 points and determine all this sort of stuff? No. Why they put this in the first section of the first chapter of the book, I don't know. Because what we're going to have to do with this one is factor it out and then software. You guys don't need to be in your phones. Just block it. So yeah, so the degree of your equation tells you how many solutions you can have. Which means if you just pick 2 points and you get these 2 points, can you draw the graph from there? No. You got to find where it's going down, find out where it's going up, where it's horizontal. For right now, I'm not going to waste our time with this type of equation. But the graph will look something like this. So, with linear equations, what do we need to draw a graph of a linear equation? Yep. We have 2 points. So we have 2 points. We're dealing with a linear equation. What all can we do if we have 2 points? So we draw, connect the 2 line to 2 dots with a line. What can we find with that information? What's that? Okay, we can find the slope of a line. What else? Yes, but in order to get that far, we have to find what? You have to find the equation of the line. Because just by the 2 points, we can't find the intercepts. We have to first find the equation of the line, then use that to find the intercepts. So it's an intermediary point. But yes, eventually we find it. So we can find the equation of the line connecting those two dots. What else can we find? We can find the distance between the 2 points. And then the last thing, we can find the midpoint between the 2 points. And that's what we're going to do. So the first thing we're going to do is find the distance. Normally, I would do the slope, but I'm going to stick with the flow of the book in case anybody's doing that in the viewing audience. So the distance. So we're going from this point to this point. We'll call this point A. We'll call this point B. Does anybody have a guess on how we'd find the distance? Do we know any formulas to find the distance? What's that? That finds slope. You've heard this equation before. That's the equation of a line.
Y1 minus.
That's the equation. That's the slope again. Let's look at this. It'll come to you when we start drawing pictures. So looking at this thing, we have a horizontal part here between those 2 points. And we have a vertical one. This creates a right angle. Do we know any formula now that deals with triangles? Yep. What is Pythagorean theorem? A squared plus B squared equals C squared. Pythagorean theorem. Where the A is the horizontal axis, B is the vertical axis, and C is the hypotenuse. That's actually telling you the distance between A and B. So how far is it from this point horizontally to this point? So this one's at 1 and this one's at 5. How far is it between there? How far is it vertically between 1 and 4? So now we have all the information we need. We can solve for C squared now. What's 4 squared? It's 4 times 4. 4 times 4 is 16. 3 times 3 is 16 plus 9. So we're looking at what number squared is 25. Yeah, so we can say that 5 squared equals C squared. That's what I was going to get to in a second. So here we could have done this. We said that C squared equals 25. We have to get rid of the square. What's opposite of square? Square root. So the square and square root, since they're opposites, they cancel. Plus or minus, what's the square root of 25? And since we cannot have a negative distance, C is 5. So the distance between A and B is 5 units. Now, that's a good question. How did we get the distance between for A? How far is it from this? Remember, the A values are the horizontal. So from this line to this line, how far are they apart? How do we get 4? Okay, what if I had 3 and 97? How'd you get 94? Subtract, yeah. So 5 minus 1 is 4. 97 minus 3 is 94. So A is equal to, this is my first X, and this is my second X. So the distance between A and A is the second X value minus the first X value. X is the horizontal axis. This one tells us the first and second. Same thing with the B. 4 minus 1 is 3. So it's y2 minus y1. It's always the bigger minus the smaller. So a squared plus b squared equals c squared actually looks like this. X sub 2 minus x sub 1 squared. Y sub 2 minus y sub 1 squared equals c squared. This is the Pythagorean theorem. Now, how do we get those values? What is point A and what was point B? What's the location of point A? A is 1, 1. What's B? So A was 1, 1, B was 5, 4. Looking at this thing, going from left to right, we get to A first. So A is our first point. It's P1. B is our second point. So this is point 1, and this is point 2. Notice these subscripts tell us which they are, the indexes. Remember, these are X's and Y's inside the points. So therefore, these are X1, Y1. This is the X and Y of the first point. X2, Y2. These are the X and Y of the second point. All we do now is label these things. So X1 was 1. X2 was 5. Y1 is 1. Y2 is 4. All I got to do now is just plug them in here. So you have this formula for the distance. So this equals the distance between the 2 points. Find the distance between those 2 points. Find the distance between 3, 7 and negative 4, 2. And there's your formula you'll be using. So what's the first thing we have to do? Now, first thing to do is label x1, x2, y1, y2. The objective of this question is to find the distance. To find the distance, we first have to find what we're dealing with. So this is our first point, and this is our second point. X1 is 3, x2 is -4. The y value of the first point is 7. The y value of the second point is 2. Once you have this, it's plug and play. So x2 is -4 minus x1 is 3. Y2 is 2 minus y1 is 7. Just once you label these, it makes it much easier. Now you just have to do the math. Since they're both negative, the answer is negative. 4 plus 3 is 7. They're opposite signs. 7 is bigger, so the answer is negative. 7 minus 2 is 5. This is the reason why we square them, because they're both negative. When you square a negative, it becomes positive. So -7 times -7 is positive 49. 7 squared is 49. 5 squared is 25. (49) plus 25 is 74. And that's your answer. That's the distance. You want to do another one? You're okay. All right. So the next thing we're going to look at is the midpoint. So I want to know, what is the location of the point halfway between A and B? The variable, to determine midpoint, we use the capital letter M for midpoint. And basically, all the midpoint really is the average of the horizontal and the average of the vertical. In other words, what number is between 1 and 5? How would you find the number between 1 and 5? That finds you the distance between there. I want to know what number is halfway between there. Well, what if these were grades? What if you made a 10 and a 50? What's your grade? How'd you get 30? Add them together and divide by 2, exactly. So if we added this one plus this one and divided by 2, so we know it's at 3. So the midpoint of this line is going to be at 3. Same thing here. 1 plus 4 divided by 2 is 2.5, which is right here. So the midpoint formula is an equation. X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. Because it's a point, it's a location. We have to do the average of the X values and the average of the Y values. No, because to find the midpoint of a curve, it's much more difficult. Because you first have to find what is the total distance between the points along that curve. And that is a whole nother level of math. So this only works for linear equations so far. Good question. That's a very good question. Okay, so let's look at an example here. Find the midpoint of the segment whose endpoints of the line segment with endpoints -4, -2, and 2, 5. So we have 0.1 is at -4, -2. 0.2 is at 2, 5. So X1 is at -4. X2 is at 2. Y1 is at -2. And then Y2 is at 5.
Oh, that's a lot.
1130. So the distance formula, X2 minus X1 squared, Y2 minus Y1 squared. So X2 is 2 minus -4 squared. 5 minus -2 squared. Negative and negative becomes a positive, so it's 2 plus 4. Negative and negative becomes a positive. So we have 6 squared plus 7 squared. 36 plus 49. Square root of 85. All it is plug and play. There's not much more to it. You guys are looking at it, it's got 3 heads. Any questions about the equation?
I thought we were finding the midpoint.
Yeah.
We're getting there. Oops,
Okay.
I just like the distance from it all. Well, no, mine says find the distance. It was midpoint, I just changed it. Okay, midpoint. But we still need to do that thing anyway. So x2 plus, or x1 plus x2. Y1 plus y2 over 2. So we have x2 is 2 plus -4 over 2. -2 plus 5 over 2. 2 plus -4, so it's -2 over 2. 5 minus 2 is 3. -1 over 1 3/2. That's the midpoint. And since it's a plus, again, creativity doesn't matter. I put in there x2, x1, x1, x2. Straightforward. Okay, there's one more section I want to cover here, but it deals with circles, which I'll wait till tomorrow to do that. Because the 2 examples we're going to do lead up to it. All right, everybody. Have a great, safe day.